Hello YouTube, welcome back to my channel. My name is Tony and today we're going to talk about this problem, jump gate number 3. And let's go ahead and read the question. Given an array of the non-negative integers array and you are initially positioned at the start index of the array, and when you are at index I, so you can jump to the right hand side or the left hand side by the increments or decrements of this particular value that you are positioned at. So check if you can reach to an index with a value of 0, and notice you cannot jump to outside of the array at any time. So basically we are jumping within this array and given the starting index, and each time we can jump to the left hand side or the right hand side by this particular array value. So what does that mean? So let's go ahead and check one of the example. So we are started at index number 5, so 0 1 2 3 4 5. So we are starting right here and the position value is 1, so which means we can start from here, we can jump to the left hand side by 1, or we can jump to the right hand side by 1. So let's go ahead and check the left hand side first. So we start with 1, we jump to the left hand side 1 by 1, so which is 3, and now we can jump either to the left hand side by 3, so or we can jump to the right hand side by 3. So if we jump to the left hand side 1 2 3, that's gonna be 2, and start from here we can keep going with our positions, or like we can start from 3 and jump to the right hand side by 3, 1 2 3. Now we are out of the box, so we cannot do that, so we're gonna abandon this operation. And so the only operation we can do is jump to the left hand side, and eventually we want to reach out to this position. Can we do that? Actually yes, because we are already in the index 1 and by here, so we can jump to the left hand side by 2, we cannot do that, or we can jump to the right hand side by 2, and which is right here, and this is the position that with the value 0, and that's the destination we want to go. And now we are finished the question. So like the algorithm comes into my mind is by using BFS or DFS, and because this week I'm doing like a BFS algorithm, so I'm gonna use BFS for this particular problems. So this is very standard, and I'm not gonna beat that horse in terms of how BFS works, and we're gonna go through the standard templates, so you'll learn the algorithm through when I'm typing. So with the BFS, basically like we want to visit all the positions we can do with the neighbors, and that's how we do. And let's go ahead and type. So we're gonna initialize the length so of the array, and that's the because we cannot go out of the box, and we just initialize the size. And then we need a queue to store the BFS. And then we're gonna initialize the queue. So what's the initial position we have is the start index. So we just add that into our queue. And we also don't wanna visit the same spot multiple times, just in case we don't wanna have the TLE. And that's why we'll have the visited position. So let's remove that, visited. And we also put the start index right here, and then we can start performing the BFS. And we're gonna pop out the position. So initially we have the start, so we just pop out the start and see where we can go. So go ahead and pop out the first position we have with our queue. And once we pop out the node, and we are popping out where we're starting with, and we want to explore where we can go. So where we can go, there are two positions we can go. So we can either go to the left, so that's gonna be node minus the array node, or we can go to the right. We can go ahead and plus the array node, and we have both positions right here, and we can start explore if we can actually go there. So how do we check? Remember, like when we are here, so we can either go to the left or we can go to the right, but when we checking if we actually can go to the right hand side, we confirm that we cannot because it's already go out of the box. So we need to double check and if we can actually go there. So how do we check that? So we basically check if we are out of the boundary on the left hand side or right hand side, and that's how we check. And there's another thing we have to check is that, so because from this position we can go ahead go to here, right? But for example, this is 1, and we can, from this position, we can also go to this position. So there's a whole bunch of duplicates we have, and because we have to visit it to remove the duplicates, and we have to double confirm that if we already visited this position before. So we just check if the position already being visited. If not, and we can go ahead and put this into the queue, and we can explore this position, and we just append this and visit it at the left as well. And the same thing happened on the right, so we just copy and paste. Oops. Alright, so I'm not gonna type this, I'm just gonna copy and paste. And now we explored the both left hand side and the right hand side. So there's another thing, like with the BFS, is that where's the terminated position? So where we're gonna go? We actually wanna go with the index value 0. So we're gonna find the index with the actual value 0, and that's our terminated position. So let's go ahead and write that. If array node, so once our node go into a position that has value 0, and we just return true, and we are done. And if none of this actually works, we just return false, and that's how we solve it. Let's try this. Yep, yeah, actually works. Okay, I'll see you guys in the next video.